Good evening, sir.
Yeah, don't mind. Evening. Let me know if you can hear me fine.
Yeah, I can hear you, sir.
Okay, cool. No, I don't anymore. You can see my screen, right?
Yes, sir.
Cool. Question, Demoy. All of your courses are online, or do you go in face to face?
Uh, no, sir. Everything is online.
Okay. Are you part-time?
Um, Technically, no, but
Mm-hmm.
because there's a low turnout of BDIT students,
Mm-hmm.
we kind of mix up with the BMIS students, and because there's low turnout for even them as well,
Mm-hmm.
they set us all for online classes. So we're technically full-time students,
Mm-hmm.
but because there's low turnout, we're doing evening classes. So we
Oh,
are kind of part-time
okay.
because
Yeah.
of that.
I
Yes,
get
sir.
you. All right, cool. I know that there's some other students that have been having issues with Canvas. I want to know if that's the same for you. I guess you and your classmates. If I post something on Canvas, will you be able to see the content?
Um, well, my canvas is working now because I had problems before, but the problem now is that we are waiting to get override.
Oh,
So I'm not seeing yours, but I'm seeing other classes, but I'm not seeing yours as yet. So
mm,
we're still waiting on the override before then.
okay. I haven't posted anything in the container yet, but I should post the last lecture slide. So let me do that now. And I don't suppose you would know whether or not your classmates are coming, would you?
Uh, I'm not sure as it.
That's
I
fine.
can try to contact him.
Yeah, can do that.
Yes, yes, sir.
Thank you. Oh, another thing. I think I put an announcement in Canvas. Oh, I guess probably you're not seeing it. Um, yeah, the announcement was just to see if you guys had gotten the recording because I got the recording. I just wanted to see if it was sent to you all as well.
Yeah, we're not going to see it until we get the
Right,
canvas. Yes,
right.
sir.
Okay. Um, all right. I guess in any case, you'll get access to it when you go on Canvas. All right. All right. Cool. I'll start at 6:15. All right. That's it. Tariq has joined. I'll get started in just a moment. All right. So whenever you guys get access to Canvas, Tuesday slides have been posted, and I just posted today's slides as well. All right. Let us begin. You can see my screen. Wait, you guys could see me doing that on Canvas a while ago. Hope I didn't show anything. Anyway, you can see my screen. You guys
Yes,
would tell me if I
sir.
saw
We can
anything
see the
illegal, right?
screen.
Okay, you never saw anything illegal, right?
No, sir.
Cool. Because you tell me. All right. So, all right. Before we jump into new material, real quick, let's just do a recap of what we covered on Tuesday. So we talked about systems integration. We talked about connecting different systems so that they work together as one. Yeah. We looked at the four types of integration architectures, or the four types of integration architecture. Yeah. Um, can anybody remind me of what the four types we discussed were called? Can I get a reminder,
The
please?
horizontal, the
Right.
spaghetti,
The
Mm-hmm.
the
vertical.
common data, and the common data.
Mm-hmm. All right, cool. Good. So as you said, yeah, you have the horizontal, the vertical, common data format, and the spaghetti. All right, good, very good. So, yeah, the vertical integration, that is the layered approach where data flows up and down. The star or the spaghetti integration, where where every system connects directly to every other system and it gets messy real fast. The horizontal integration, where you put the middleware in the middle and everything connects through that central layer. And then you have the common data format, where everyone agrees to speak the same language. Example, XML or maybe even JSON, right? Good. Oh, I need to move to the next slide. Sorry. Good. Where was I? So yeah, we also talked about the key concepts like continuous integration, talked about enterprise application integration, integration platforms, and interoperability. Yeah. And we went over the skills that you'd need, whether it be for software engineering, hardware knowledge, understanding protocols like REST and SOAP. I don't think we really talked much about REST and SOAP. I think I maybe mentioned, but I don't think we talked so much about them. We talked about problem solving skills, different types of skills you need to implement these integration systems. All right. Or sorry, these types of integration. So that's all about the what. Um, the what are the types? What are the concepts? What are the skills that you need? Today, we're not going to be talking so much about the what since we covered that. What we're going to be talking about is the how. So, how do you actually go about doing an integration project? What strategies do you use? And um, yeah, the how is going to be what we refer to as the integration methodologies. So we talked about the different types of integrations. Now we're going to be talking about the ways that we can implement these actual systems. Questions so far? We're good?
Good, sir.
Yes,
Good,
sir.
sir.
Yes, sir.
All right, cool. Let's see. Right. So an integration methodology is basically a game plan. It's the strategy that you choose for how you're going to carry out an integration project. Think of it this way. Um, in the last class, we talked about the types of integration, which is about the architecture. So that's like deciding whether or not, or sorry, whether you're going to build a house with one floor, two floors, or if you can put on a split level. The methodology, however, is how you're going to go about building it. Are you going to build the whole house all at once? Or are you going to build it room by room? Are you going to start with the foundation and work up? Or are you going to start with the roof and work down? Make sense? Can that make sense, right? Starting with the roof
Yes,
and working
sir.
down. Yeah. All right, cool. So yeah, the methodology that you choose matters a lot because it affects your timeline, it affects your risk level, it affects your budget, which is very important. It and honestly, whether the project succeeds or fails. A bad methodology choice on a complex project can bring about disaster. There's several methodologies that are commonly used in system integration, and we're going to go through each one of those today's lecture. The main ones are the Big Bang, incremental, top down, bottom up, and there are some hybrid or phased approaches as well. So hybrid meaning like you have ones that include aspects of the other, like in a merged way, and you have the phased ones that are like they take some parts of one and merge it with other parts of the other. So it's like a combination or a mix. Okay, cool. So we're gonna start with Big Bang integration. Um, this one is the most dramatic one, Big Bang integration. The name sort of kind of tells you what it is you're going to have to expect. With Big Bang, you develop and test all of your integration components separately, and then you connect everything all at once. You flip one switch, and the whole integration system goes live. So that's what I mean by Big Bang. Like you just do all the work all at once, or not all at once. You do all the work first, and then you go live one time. So that's why I call it Big Bang, because it's just one go live. Think about renovating your house. The Big Bang is like moving out, gutting the entire house, doing every single room at the same time, and then moving back in when everything is done. One move out and one move back in. Yeah. Now, question for you. What do you think the advantage of something like this is? An advantage of an approach like this? Why would anyone choose to do it all at once? Can anybody tell me? What do you think?
So like a faster approach.
Mm-hmm. Okay, so you're thinking about speed, yeah?
Yeah.
Mm-hmm. Okay, good. So yeah. Mhm.
We did this in ERP, this concept like the Big Bang and phase model and this kind of stuff.
Oh, you did. Okay.
Yeah.
Oh, all right. Well, that's good. That means I can expect to get more answers from you guys then. Yeah. So yeah, you're correct. The big advantage is speed. If everything goes well, you get your integrated system up and running in the shortest possible time. And there's only one transition. Yeah. You switch from the old way straight into the new way all at once. There's no in-between state where some systems are integrated and some aren't. But there's a problem, and it's a big problem. What happens if something
Sure, look
goes
like
wrong?
that might drop off.
Oh, did he? Oh, okay. Well, hopefully he'll have the recording after. Did he just drop off a while ago? I didn't notice.
Look, so
Oh, all right. Well, he should be fine. Hopefully he'll come back. But yeah, so I was saying that there's a problem, and it's a big problem. And that problem is what happens if something goes wrong when you flip the switch? Before I continue, can you say what one of the things, or like, can you give me an idea of what you think could be a problem or why this would be a problem?
so like if there's an error with the system integration, the whole
Hmm.
thing would basically be at a halt and nothing can be done.
Yeah. So it very much depends on the type of system that you're working on. So I guess like one way I'm thinking about it, for example, if it was maybe like a vertical system integration, if you're supposed to update everything and one of them don't get updated properly or fixed or, um, re-overhauled properly, since it's kind of like a chain, the flow of data is like a chain. If one of them not working properly, then it's going to affect the entire system. So yeah, you're right. If something goes wrong at one step of the way, then it's going to affect the whole system. So yeah, if something breaks, it's extremely hard to figure out where the problem is because everything changed at the same time. That's another thing we have to consider. The fact that we were making changes to the whole system all at once, because we changed everything all at the same time, when we flip the switch and go live, something go wrong, unless you have eyes on each individual part, like whether it be in the form of logging or physical visuals on each of the parts to see how the system goes wrong, it might be a problem where if you only have eyes on the end product, it's going to be difficult for you to see exactly what caused the problem. Um, so, right, when you flip the switch, you have different questions that you could ask yourself. You could be asking, is it system A that's the problem? Is it system B that's the problem? Is the data format an issue? Is the networking problem? Because you did all the work at the same time and you made all the changes at the same time, it's going to be difficult to know, or it may be difficult to know because you changed everything all at once. And that's going to make troubleshooting very, very difficult. So, with that, Big Bang is high risk. It can work for small projects where there aren't very many systems involved, or where the integration is straightforward. But for a large, complex project, most experienced integrators will tell you to avoid Big Bang unless you have a very good reason. That good? Any questions, Anna?
Answer for
Mhm.
none, sir.
All right, cool. Damo, you fell off a while ago. You good? Not sure if you missed anything.
Yes, sir. I think
Okay.
I'm catching up.
Your audio is low. I'm not hearing what you're saying.
You can hear me now?
I guess, yeah.
Okay. I guess I'm catching up
Okay.
to where
All
we
right.
were.
No problem. If you have any questions, you can let me know. Okay.
Yes,
So,
sir.
yes. Mhm. So, that's going to bring us to incremental integration. You can think of it as the opposite of Big Bang. With this approach, you integrate systems one at a time or in small groups. You connect system A to system B, and you make sure that works. And then you connect system C, then you make sure that works, and so on. Yeah. So you take it one step at a time, incrementally. Going back to the house renovation analogy, incremental is like doing it room by room. So you renovate the kitchen first, You use the kitchen, make sure everything works, make sure the plumbing is good, make sure the appliances are all connected. Then once all that's done and confirmed, you move to the bathroom, then the living room. And at every stage, um, you make sure to have your checks to make sure everything is working properly. And when you're finished, you have a working house, right? And the advantages are pretty clear. The risk is much lower because if something breaks, you know exactly what changed. Uh, it was the last thing you did or the last thing that you added. Troubleshooting is way easier. You also get value early because parts of the system are integrated and working before the whole project is finished. But there are disadvantages. Disadvantages to this is that it may take longer. And during the process, you're in this in between state where some systems are integrated and some aren't, which can be awkward to manage. Um, it might need temporary workarounds to handle systems that haven't been integrated yet. But overall, incremental is probably the most commonly recommended approach for most integration projects, especially complex ones. Questions? We're good?
Good, sir.
Yeah. And we see how it compares to the Big Bang and we see the drawbacks and the disadvantages, advantages.
Yes, sir.
Yes, sir.
Mhm. Okay. All right, let's talk about top-down integration. So now top-down and bottom-up are they're really variations of the incremental approach, but they tell you the order in which to integrate things. Top-down integration means that you start with the highest level components first. That's the user-facing parts, the main control modules, the big picture stuff. And then you work your way down to the low-level components. Think about building a website. Top-down would mean you build the main page and the navigation first with placeholder data and dummy connections. You know what I mean by placeholding data and dummy connections? You guys have done like mobile app development, I think, or web one
Yes,
and web
sir.
two. Yeah. Okay. So when I say placeholders, we're familiar, and the dummy connections. Um, the advantage for the top down is the stakeholders, like for example, your managers or your clients, they can see the progress early. They can interact with the high level interface even before the underlying systems are fully connected. Um, this is good because it builds confidence and it helps catch design problems early before you even built all of the low level details, right? So, with that website design example, you do the front facing parts first so that somebody that is looking at your progress, they have something to look at. Even though it doesn't actually maybe do what it is supposed to do, at least they have something, the stakeholders, at least they have something to look at and interact with. So they have an idea of what the end goal will be able to do or will be able to look like, right? Um, but disadvantages is that you need to create what we call stubs. They're temporary fake components that simulate the low-level systems that haven't been built yet. And creating and managing stubs, it takes effort. And there's always a risk that a real system behaves differently from the stubs you created or from the stub that you created. One of the reasons why creating stubs, or rather another reason why creating stubs is difficult, as I said earlier, it takes effort. So in some cases, it might feel like you're doing double work. The stubs that you're going to create just to stand in as a placeholder, we spend time, we spend effort to design those, only till later when we're actually building out the low level details, replace them with the actual thing. It may not take the same amount of effort or the same amount of time as usual, but it does take some amount of time. And time is money. So it's not to say that we're wasting money, but it does take a certain amount of resources that could be effectively used otherwise. Tell me if you get what I'm saying.
Understand it, sir.
Okay. Right. Okay. Let's talk about the bottom up integration. Bottom up is the reverse. So you start with the lowest level components first, the individual services, the database connections, the basic data exchange modules, and then you build upward. Sticking with the website analogy, bottom up means that you first make sure that the database queries work, then you build the API layer on top of that, then you build the business logic, And finally, you build the user interface last. Um, and again, I just want to check in. I hope I'm not losing anybody with my jargon. I'm assuming that we'd have gone through the other courses that would make these things relevant. Like we'd have done Web 2, I
Yes,
guess.
sir.
Yeah,
Yes,
and
sir.
we'd have
Entry Web
built out
2.
our
Yes,
APIs
sir.
and stuff. Okay, cool. Good. Question. Um, you're doing any, you're in fourth year. I don't know if you're doing any programming courses now, are you?
Oh,
No,
sir.
sir.
The programming courses anymore.
Oh, you don't. Okay. All right, no problem. All right, let me see. What was I saying last? So the advantage, yeah, the advantage is that you are building a solid foundation. Each layer is thoroughly tested before you add to the next layer on top. When you finally get to the user interface now, you know that everything underneath is reliable and working properly as intended. Yeah. But disadvantage. The disadvantage is the opposite of top down. Stakeholders can't see anything useful for a long time. And this is actually something that I think I face pretty often. Um, Me personally, like when I'm building out some application, I guess maybe I have a bias. I tend to start from the back end first because I like doing back end stuff. Front end, in terms of front end and design and stuff like that, I'm strongest in that. So I tend to leave that for last. And whenever I'm doing back end work, I can always use other applications to test out the requests that my back end is supposed to be able to handle. So I'm not really super dependent on a front end. But just like what I was saying a while ago with the disadvantages of the top down, sorry, is it top down? The bottom up, sorry. Is that, if I'm building this out for somebody, it's gonna be a while before they can actually see what this application will do or what it will look like because I'm too busy working on the low level stuff, the back end stuff. And it's only until, much later in my development I can show them what the application does. Right? Where was I? Yeah. So I was saying stakeholders can't see anything useful for a long time. You might be weeks or months into the project, and all you can show is a bunch of database connections or API calls, which is not very useful, especially if you're not a technical person. There's nothing visual. So that can make the people nervous, especially if they're the ones funding the project. Um, it'll be hard in a case like that to convince the stakeholders, if they're not technical, that what you're doing is on track because, all you can do is explain to them what you're doing. You can't show them it working. And even if show them, as a matter of fact, I don't even want to say show them the code because stakeholders don't want to see code. They don't want to see database connections, all that stuff. So it wouldn't even make sense for you to try to show them. So let me see. You also need what we call drivers, which are temporary components that simulate the higher level systems. So you can test the lower level ones. Similar to what I was talking about, where if I build my API and I don't have the front end that I can use to test out the applications or the API, I can use other applications that we call drivers to make tests or perform tests that will show me that my APIs are working effectively. Do you guys know any examples of any applications like that? Based on what I said a while ago? Did what I said a while
Can't
ago make
name
sense?
any off the top of my head, sir.
None off the top of your head. Okay. But you have experience building out APIs, right? Like server-side applications? Or am I saying
Not
it
In a
weird?
way,
In a
in a
way?
way.
Give me an example of what you mean. So tell me why in a way and not yes.
Uh,
All right,
let me
before
take
that, let me ask, do you know what an API is?
sir, is almost like software.
So it is software for sure. All right, you said that you have experience building websites, yes?
Yes, sir.
Yes,
All
sir.
right.
We use the API for in Web 2, or I can't remember that. I'm
Okay, so
trying
you
to
did
remember what we
API stuff in
use.
Web 2. Mm-hmm.
I'm not sure I remember specifically what we did with the API. And,
Okay. Did you do Web 3?
yeah, but I don't think we
Mm.
Yes,
did
sir.
anything with APIs in Web 3.
Oh, okay. All right. Tell me what I mean when I say front end, when I'm talking about website design.
The side that the client and other users will be able to see.
Right, good. So that's the website part, the
Yes,
part that
sir.
the user sees. The backend, however, that is what controls the logic or the functionality of the website.
Yes,
So
sir.
we'll have a website that, for example, let's use a restaurant. Um, the restaurant on the front end will display the menu and it will tell you the prices of each of the dishes that they have available. And when you place an order, the order does not stay on your phone or doesn't stay on your computer. That order needs to go somewhere. So a request is made from the front end or the web page off to some server-side application or some API that handles the request and then lets the restaurant know on their side that an order was placed. Yeah. So that's what I mean when I say front end, back end, and the API would be the back end part. So going back to my example of drivers, if it's a case where you start from the back end and you handle the functionality, you would want to test out the functionality of your back end by most easily having a website that we could use to, put in a fake order. But if you don't have the website because you're still only working on the front end, you may want to use a driver to simulate these requests. And in my experience, one really good driver or one application that you can use to test out these API calls would be Postman. Have you ever come across Postman in any of the years you've been here?
Yes, sir. First time I'm hearing about it.
Okay. All right. Well, if it's something that you are interested in going forward with, website design, Postman is a good tool to have. Yeah. Okay. So let me see now. Where was I? So a driver is a temporary component that simulates the higher level systems. So you can test the lower level ones. It's similar to stubs in top down, uh, just in the other direction. Yeah. Okay. So question for you. Let's say you're integrating a new online payment system for a retail business. The system needs to connect to the bank's API, the inventory database, and a customer facing checkout page. Would you use top down or bottom up for this? And whichever one you choose, tell me why.
I repeat, sir.
So I was saying, let's say that you're integrating a new online payment system for a retail business, like a supermarket. So you want the supermarket says that they want to be able to take payments online. The system needs to connect to the bank. It needs to connect to the supermarket's inventory database. And it also needs to have a customer facing page where it shows all the products that they have available. And like, when you go on Amazon, you have a checkout page and a cart and all something there. So I'm asking, in a case like that, would you use top down or bottom up? And I want to know why. I want to get an answer from both of you.
It's
Sorry.
bottom up, sir.
Okay, so you said bottom up. Tell me why you said that.
Since the system is so complicated, you want to focus on that first before you go on the front before you go on the front end,
Okay, you had said bottom up, right? So you said that you want to focus on the low level parts
the back,
first,
the back end of it.
the back end first, and then work your way forward or work your way up. Is that what
Yeah,
you said? Okay. Then
yeah.
why?
It's
Let me get your. Oh, go ahead. You can continue.
all right. Don't mind go, sir.
All right, no problem. Then
So
why you
yeah,
can
I
go ahead.
also so I also agree with the bottom-up integration starting from
Mhm,
there.
mhm,
Since the business wants a lot of functionality first before they really put the focus on letting customers do certain things,
mhm,
since they want to have the connections to the bank. You said the bank, right?
mhm,
The banking and then the connections like that. It
mhm,
would be best to start with the back
mhm.
before implementing the section where the customer will see.
Right.
So
Okay.
it creates a lot less complexity further on since
Mm.
you get everything from the beginning.
All right. All right. No problem. So just one thing I want to point out that there's no single right answer for this. So even if you had said, what's the other one again? You said bottom up. Even if you had said top down, that would have been equally correct. And here's the reason. Yeah. I asked the question because I wanted you to think about the different trade-offs. I wanted you to think about, why each one is more important to you, given the type of project that you're looking at. So your answers were both good. And honestly, in a real world situation, a lot of teams use a combination. They might start with bottom up for the critical backend stuff like the bank connection, but then they go top down for the customer facing parts so they can get user feedback early in the process. So that's what we call a hybrid or a sandwich approach. Yeah. Okay. So let me give you a quick summary so we can see them side by side. For Big Bang, we do everything at once. Uh, Fast if it works, but it's high risk. It's good for small and simple projects. Incremental now is one piece at a time. It's low risk, easier to troubleshoot, but it takes longer. It's good for most projects, especially the complex ones. Top down now, we start with the high level stuff and work your way down. And it's good for early stakeholder buy-in, but you need stubs. Bottom up, we start with the foundation and we build up. It's solid and it's reliable, but stakeholders can't see results early and you need drivers. And then you have the hybrid approaches, which combines strategies based on what makes sense for the different parts of the project. So it very much depends on, the different parts of the project and what is needed for each one. And the key takeaway here is that there's no single best methodology. The right choice depends on the size of the project, the complexity, the risk tolerance, timeline, and honestly, the expectations of the people paying for it, which is the part of it that I really don't like. Yeah, so you kind of have to cater to the person that is, or the entity that is funding the project. Sometimes it means that you don't get full creative control. And I mean, honestly, creative control should really be held in the hands of the person who wants the project, unless they don't know what they want. Because there are times when the stakeholder who asks you to build this thing, they tell you what they want, but what they ask for don't make sense. So then in that case, you have to step in and you have to make executive decisions and take control of it. Questions? Are we okay so far?
Okay, sir.
All right, cool. Right. Okay, so choosing a methodology and the real world factors that we have to consider. Um, so how do you actually choose then, right? In the real world, there are several factors that drive this decision. First, project size and complexity. The more systems involved and the more you want, the more systems involved is the more you want to lean toward incremental. The big bang gets riskier as complexity increases. The second thing you want to consider is risk tolerance. Some organizations are very risk averse. Maybe they're in healthcare or banking where downtime can have serious consequences. Those organizations almost always go incremental. You guys what I mean? Get what I mean by that? In terms of the risk averse, like the examples I gave being banking and healthcare. Can you tell me why you believe it would make sense for them to be risk averse? Let me see if I can hear from both of you. The examples I gave were banking and healthcare. You guys not hearing me?
Yes, sir. We're hearing you. Just
Yeah, man.
thinking it out.
Okay. Don't overthink it. Tell me why a hospital would not be interested in taking risks. Start with a hospital.
Oh,
Mhm.
The
because
information will be too sensitive, sir,
No, 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 no.
to
Yeah, I made
lose
it too
answer.
deep. Yeah, I made it too deep. Hold on, let me hear what Damoy was going to say. Because Damoy said, oh, why would a hospital not want to take risks?
because they're dealing with the people. So if
Dealing
they're
with,
dealing
Go on.
so if they're dealing with the people, they
Mhm.
don't want any of the information to go wrong
All
at
right.
all.
Tona made the same thing, but now I made it too deep.
All right, sir. They don't want any downtime with any issues
Why not?
because a hospital setting is a 24/7, a 24-hour setting where you want to always be operational.
I guess, but there's a particular thing that I want you guys to consider. Hospitals deal with people's life and health and well-being. So if you have a system that is going to be taking control and managing somebody's health and well-being, and something go wrong, somebody could die. So that is the reason why they want to be risk averse. They don't want to take any unnecessary risks because one wrong slip could mean somebody dies, and that's bad. So that is why, major reason why hospitals are risk averse. Tell me if you understand what I'm saying now.
Yeah, I
I get
understand
the
that.
Yeah,
sense,
I
sir.
wanted you to think in the dramatic sense. It's because, we're dealing with people's lives. It's not something to play with. We can't guess and spell and say, oh, maybe it can work because maybe it can mean somebody dies. Yeah. What about the bank
Yes, sir.
one? Since I gave you the example of the hospital, tell me why banks don't take risks.
Because they don't want to lose all their money.
That is it. You don't play with money, especially when it's not your money. If you have your own money, you can do whatever you want with it. But banks, they don't deal with their own money. They deal with other people's money. And money, serious. You don't play with money. So if you have some system that you want to make changes to, and you say, let's just try a thing and see if it works. And when you flip the switch, all the money gone. What do you tell Michael Leachin when all that money gone? You can't tell him sorry, right? Because people money. Make sense?
Yes, sir.
Yes, sir.
Okay. Cool. Where was I? So I was talking about risk tolerance a while ago, right? Um, and those types of organizations like healthcare and bank, they always go with incremental because they'll be able to see at every step of the way what changes were made. If something goes wrong, they'd be able to catch it early and fix it. All right, so the third thing now, since I said earlier a while ago, is timeline and budget. If you're under extreme time pressure, Big Bang might be tempting because it's technically the fastest, but you have to remember that it's only true if nothing goes wrong. And things almost always go wrong. That's kind of the mindset that you have to take when you're building out these systems. You have to account for something going wrong in the worst way. The fourth thing that you have to consider is the stakeholder exceptions. Sorry, expectations. If your client wants to see progress every 2 weeks, top down or incremental makes more sense because you can demo working pieces along the way. And the fifth thing that we need to consider is the nature of the systems themselves. If you're integrating legacy systems, legacy system is an old system that you have to keep running for years, like one that you are not allowed to upgrade or upgrade, I guess. Um, you probably want to be very careful and go into incremental because legacy systems are unpredictable usually. They might have undocumented behaviors or dependencies that only show up when you start connecting to other things. I want to talk on that for a sec. Is that um a term that you've heard before? Legacy systems. Are you familiar with that?
Yes, sir. We
Yes,
have
sir.
heard of it.
Okay,
Yes,
you've heard
sir.
of legacy systems. And I think I would have made a reference to legacy systems in Tuesday's class when I was talking about how some banks will rely very heavily on very old computers. So it's a case where those very old computers were managed by people that knew how to use very old computers. It is a case where, maybe they don't play very well with new technology. Or if they do, it's a case where they're currently connected to the system and you don't know if you'll be able to get it working again if you plug it out of the system and plug it back in. And that would come in the form of undocumented behaviors. We don't know what these systems are dependent on, especially if you don't have these documentation. So it might be a case where, if you make a change to those old systems, you may find that making a change would require more than what you thought it did. Just because you have a visual on the top, you don't know what's going on in the behind the scenes because of lack of documentation or lack of, I guess, support from the persons who were using it or built it back in the day. So these things become things that you have to consider as part of the risk that you're taking. So you may want to take an incremental approach because if you take the, what's it called? I almost said spaghetti. Um, Big bang approach. If you take the big bang approach with that and you don't do your testing incrementally, you flip the switch and no light comes on. Yeah. All right. Tell me if we're good. Let me know.
Yes, sir.
Yes,
Mhm.
sir.
Right. All right. Let me see now. Quick scenario exercise. So let's do a quick exercise before we wrap up. And I know I said wrap up, we're only gone for an hour, but the content you guys seem to understand really well, and it's only two of you for the most part. But yeah. So I can give you a scenario, and I want each of you to tell me what methodology you recommend and why. All right. I don't have it written down. All right. So scenario is you have a mid-sized hospital in Kingston, and they want to integrate three systems. Their patient record system, the pharmacy system, and the billing system. So right now, the nurses have to manually enter patient information into all three systems separately. They want all three systems to share data automatically. The hospital can't afford any downtime during the business hours. Which methodology would you use? I'm gonna give you a few key points. I think consider the fact that this is a hospital.
Sir,
Um,
I'd say incremental.
okay. Incremental
Because
specifically. Or go on. I'll listen to what you're saying.
you can test each part of the system what you're going to implement, and if there's a problem to arise, you can find out where it is easier than the other
Hmm.
methods.
Okay. All right. That was Tyreek, right? Damo, you can go ahead. Let me hear what you have to say. Damo there?
Yes, sir. I'm here.
Mm-hmm.
I'm
Mm-hmm.
just weighing the options.
Mm-hmm. All right. Let me see if I can get some more to you. Tell me if you agree. All right. No, actually, you tell me. Would Big Bang make sense in a case like this? It being
Big
a
Bang has
hospital. Mm-hmm.
well, Big Bang would work. It would not. Well, I would say it would work in the sense that it would automatically just have the system ready up, so
Mm-hmm.
you wouldn't have as much cost. It wouldn't be as much
Mm-hmm.
cost. It wouldn't be as costly as the other options,
Mm-hmm.
and it would also just get it over with in like the one time. But it could come up with a load more issues.
Mm-hmm. That's correct. And there's another thing that you have to consider as well. So remember, with the way how the Big Bang methodology is set up, yes, everything would be working all at once, assuming there are no issues. But remember, with our Big Bang stay, before you get everything up and running, everything have to shut down and lock off first.
Yeah,
Yeah, which is not good because that
it's
means
a
you'd have to
hospital.
close the hospital. Yeah.
Yeah,
And we don't want to close the hospital. So that's why I would not think that Big Bang is a really good idea. So like aside from the risk is one thing. But the fact that we have to shut down the whole hospital, that alone is reason enough for it not to be the best idea. Make
yeah,
sense?
yes, sir.
All right.
So
Mhm.
so from from that, I would say
Mhm.
I'm not sure if a hybrid could be used, but I would say incremental would be
Mhm.
a better option.
Okay. I get what you're saying. And it's a good thing
Yes,
that you
sir.
mentioned the hybrid. But yeah, based on what the tone is say, incremental makes the most sense here. Maybe start by, for example, connecting the patient records to the pharmacy first, since that might be considered the most critical part for patient safety. And then maybe after that, you could add billing. The bottom up might work well here because you want the data connections to be rock solid before anything goes live to the end users. Um, and you may also want to do a phased rollout. So a phased approach where maybe the pilot with one department first rolling out to the hospital. Oh, sorry, where you have like a pilot, like you have one part of it exposed so that you can test to see if things are working properly while we're currently still operating other parts of it otherwise. Yeah. So it very much depends on mostly what it is. But I think in this case, the incremental methodology works the best. Yeah. So yeah. Um, and notice how the constraints of the scenario, for example, no downtime, it's a healthcare setting, those basically rule out certain options and push you toward others. So that's exactly how it works in the real world. The context of the project or the scenario tells you the methodology that you want to use. Yeah. Okay. And then no. All right. So some key takeaways, some stuff for us to remember as we leave here today. Um, Number one is a methodology is a strategy for how you execute an integration project. It's different from the integration type, which is about the architecture. Number two, Big Bang is all at once, fast but risky. Incremental is piece by piece. It's slower but safer. The top-down and the bottom-up approach tell you the order of integration. Top-down starts with what the user see, and bottom-up starts with the foundation first. The fourth thing that we need to cover is, or just note, is that there's no universally best methodology. You choose based on the project size, the risk tolerance, timeline, stakeholder needs, and other systems involved. And the fifth thing, in the real world, hybrid approaches are most common. You might use different strategies for different parts of the same project. So it very much depends on what the project entails. Yeah. Questions?
Oh, sir.
Mhm. Okay. All right. I I don't know. I guess I feel like for the most part, unless this wasn't clear, that should be it for unit one. So that means starting next week, Tuesday, we'll be starting unit two, and we'll be talking about product life cycle and how it applies to system integration. Yeah. Um, I will most likely. Did I cover anything related to the course structure last week? I don't think I did. Um, no, yeah, I did. I told you about the coursework, right? And how you'd be getting the coursework delivered to you.
Yes, sir.
Yeah, okay. I'm going to talk more in detail about that starting next week. Um, but yeah, so that should cover unit one. Um, yeah,
Sir,
so that should be it. Yeah, question.
wait, sir, it says, all right, for you said methodology, but you said there
Mhm.
was something else, otherwise on methodology. Are we talking about?
The actual integration. So like the integration is it talks about, wait, you mean what we did last class? What do you mean?
All right, sir,
Something I said just now?
yes, sir, the
Oh,
method when we're talking about the methodology section, the
mm,
number one.
number one. So methodology is your strategy for how you execute an integration project. And it's different from the integration type, which is about the architecture. So remember, on
Oh yeah.
Tuesday we talked about the integration types.
Oh, the four different types.
Yeah, the four different types. That defines your architecture. But the methodology says how you implement. So, like I said earlier, the
Big
um
Bang and then
right,
all
yeah,
the
yeah,
rest
yeah.
of them.
So those are the what, and what we talked about today is the how. Make sense?
Okay. Yes, sir.
Mm-hmm.
Understand now.
All right, cool. Um, all right. One thing I would like to get out of the way. You said that you don't have access to Canvas yet. All right. I guess you can wait. I was thinking
I have
about how
access to Canvas, sir.
oh, right, yeah, but you don't have access to the content of the course, right?
Let me check real quick, sir. I'm
Mm-hmm.
going to the content.
Tariq, you can see. this class in Canvas?
Yeah, I can see it. I can see system integration.
Oh, you can? Can you see the stuff I
Yeah.
posted? I posted 2 slides today. Can you tell me if you can see that?
For week one,
Yeah.
yeah, I see them.
Oh, all right. So you can see the stuff.
Oh, so it's just me then.
Hmm. All right, let me ask a question. If I post something on Canvas, Tariq, would you be able to communicate it to the other 2 people? Like, is it something that
Yes,
you
sir.
already have set up? Okay. All right. I still won't rely very heavily on it because I know that not everybody has access to it at the moment. But in the event that I need to get something out, I will send it out and I'll ask Tariq to communicate it to Demoy. And what's the other guy's name? Was it Marination or something like that? Marination.
Romain Higgins, sir.
Oh, okay. His Zoom name was something else. Okay. All right. So yeah, that's it. That's where we're going to end for today. So we meet again on Tuesday. All good?
Yes, sir.
Mm-hmm. All right, cool. Thanks. Enjoy the rest of the evening.
Same to you, sir.
Thank you.
Yes, sir.